10 years after the release of The Martian, a planetary scientist has taken a look at the current state of Mars exploration. The Martian, the best-selling novel by Andy Weir, predicts that by 2035, NASA will have landed humans on Mars 3 times, perfected return systems to Earth, and collaborated with the China National Space Administration. Now, a decade has passed since the film's theatrical release in 2015, with just 10 years left until that fictional timeline. At this midpoint, Mars exploration appears a bit different than depicted in The Martian, with more discoveries and, of course, controversies. Ari Koop, a planetary geologist collaborating with NASA missions studying Mars, closely follows the sciences and policies related to space exploration. In 2010, the U.S. National Space Policy set goals for sending humans to Mars in the 2030s. However, in 2017, the Space Policy Directive 1 from the White House shifted NASA's focus back to the Moon, a program later named Artemis. Although the idea of crewed missions to Mars has gained significant popularity, NASA's actual plans for landing humans on Mars remain fragile and unstable. Particularly in the past decade, it has been robotic missions, not human ones, that have driven progress in Mars exploration and inspired human imagination. Since 2015, orbiters and rovers have transformed scientists' understanding of Mars. These missions have offered numerous insights into the planet's climatic changes over time. Mars's climatic changes, as Earth's neighboring planet, reflect solar system processes that have also impacted Earth, particularly during the time when life was just beginning to form on our planet. For this reason, Mars has become a focal point for research answering humankind's age-old questions: where do we come from? And are we alone in this universe? The rover's Opportunity, Curiosity, and Perseverance have traveled dozens of kilometers across the Martian surface, examining the rock layers that act as historical documents of the planet. Geologists, studying the sedimentary layers or rock formations stacked like layers of a cake, have pieced together a living narrative of Mars's environmental transformations that are far broader than what is currently happening on Earth. Mars was once a world filled with active volcanoes, glaciers, lakes, and flowing rivers, resembling early Earth significantly. However, its core cooled, its magnetic field failed, and its atmosphere gradually dissipated. The bare surface of Mars still harbors evidence of that era, from landscape patterns to sedimentary layer sequences and mineral compositions. In 2022 and 2023, Koop and colleagues from Northern Arizona University and Johns Hopkins University published detailed analyses of this layered material. These analyses were based on satellite images obtained from the Mars Reconnaissance Orbiter and the Mars Odyssey spacecraft. Researchers, using infrared imaging and surface feature measurements, attributed several different sedimentary layers to similar periods of formation and gained significant insights into the unstable and fragmented nature of the land in this region. Since water tends to bind rocks together well, these loose materials suggest that about 3.5 billion years ago, this area entered a dry period. To facilitate scientific discussions about this area, researchers, in collaboration with the International Astronomical Union, named several unnamed craters mentioned in the narrative. For example, one of the craters that Watney passed by is now called the Kozova crater, named after a city in Ukraine. There are more things left to discover. Despite rapid advancements in Martian science, many unanswered questions remain. Scientists are still uncertain about the exact age, past atmospheric conditions, and potential signs of life in various types of Martian surface rocks. For instance, the Perseverance rover has recently drilled into unique rocks containing organic compounds, carbon-based. Organic compounds are fundamental building blocks of life, but we need more precise analyses to identify any living microorganisms within these rocks. The ongoing Mars sample return mission aims to address these fundamental questions. For the first time, this mission will bring back unprocessed pieces from another planet to Earth. The Perseverance rover is currently storing rock and soil samples, including those containing organic compounds, in sealed tubes. In the future, a specialized lander will be required to collect these samples and return them to Earth. Once the samples return to Earth, researchers will be able to examine them with tools that are several times more sensitive than any instruments that could be installed on a spacecraft. Through the Mars Sample Return mission, scientists will gain far more information about habitability, geological history, and any signs of life on the red planet than from human crewed missions. This perspective has led NASA, the European Space Agency, and other organizations to invest around $30 billion in robotic Mars exploration since the 1960s. This investment has yielded remarkable results. These efforts have spurred rapid advancements in robotics technology, remote communication, and materials science. For example, Mars mission technologies have contributed to the development of better sutures for heart surgery and the advancement of autonomous vehicles. Additionally, these endeavors have reinforced NASA and the United States' position as leaders in modern exploration and technology, inspiring millions of students toward the sciences. Now that NASA's scientific budget is at risk of being nearly cut by 50%, the U.S. may lose its entire planetary science program and robotic operations, including the Mars Sample Return mission.